Welcome to another video from explainingcomputers.com. This time it's very exciting indeed because I've finally got my hands on one of these, a Radxa X4. And what this is a single board computer with roughly a Raspberry Pi form factor, but it's got an Intel N100 processor. So let's go and take a closer look. Right, here we have our Radxa X4, which for me is one of the most anticipated new SBCs I've looked at for some time. It's available with 4, 8 or 16 gigabytes of RAM and with or without 64 gigabytes of onboard eMMC flash storage, with prices starting on AliExpress at $62.88 or £49.19 for a board with 4 gigabytes of RAM and no eMMC. However, this particular board is 8 gigabytes with no eMMC, which was what was available when I placed my order, and it cost me $82.66 or £75.79. And I also purchased this, which is the official cooler. It's also a sort of case, as you can see, and you've got to have some kind of cooler on an N100 system because the CPU can get very hot indeed. But for now, let's leave that aside and go back to the board. Hello, and we'll take it out of the box. Nice simple unboxing like that. Just pop a little box, and here we are. It's actually in an anti-static bag, which we don't always get these days, do we? And it's not sealed, as you can see, so very easy to get in. And there we are. There's our new single board computer. And the first thing I'm really pleased to see here is it actually got a real-time clock battery fitted. And the reason I'm surprised by this is because the last 2 Radxa boards I've opened up, you've had to supply your own real-time clock battery. Anyway, in addition to being excited about the real-time clock battery, we can see that this very much has the look of a Raspberry Pi, and indeed I think we should compare it to some of its SBC friends. And so, over here, I've got a Raspberry Pi 4 and a Radxa Pi X, which was Radxa's first x86 single board computer based on an Intel Atom Z8 350. So let's bring in our N100 based X4 and put it in the middle like that. And as we can see, very similar form factor, slightly different down the edge. It's got a little bulge down here around the GPIO, which we don't have on the other boards. But other than that, pretty much a drop-in replacement in terms of form factor for a Raspberry Pi. And I also find it interesting that the Radxa Pi X has got this very large heatsink underneath, and we're going to get a very similar cooling solution fitted with the official heatsink case on our new X4. But for now, let's leave cooling aside and check out the X4's specifications. As you probably noticed earlier, the X4's N100 processor is mounted under the board. And it's a 13th generation Intel chip with 4 efficient or E cores clocked at up to 3.4 GHz, as well as Intel UHD graphics with 24 execution units. Here it's coupled with 8 GB of low-power DDR5 4800 RAM, and also on the base of the board we have an SPI flash chip that contains the board's BIOS, as well as headers for a cooling fan and the real-time clock battery. If we turn the board back the right way up, like that, on the top we can see we have an M.2 slot that's M-keyed to take a 2230 NVMe SSD, and which offers a PCIe 3.0 4-lane interface. Next to the M.2 slot we also have a wireless module, and this offers either Wi-Fi 6 and Bluetooth 5.2 or Wi-Fi 5 and Bluetooth 5.0, depending on the exact model of X4 that you purchase. And whilst we're looking at this part of the board, we can also note the power button down here. If we turn to the main lung edge, we find a USB-C connector to power the board, as well as a 2-pin power input header, and these require a 12-volt 2.5 amp supply, so different to a Raspberry Pi that requires 5 volts. Next, we have 2 4K micro HDMI connectors, which I personally find somewhat disappointing, as I would have been far happier with a single full-size HDMI port that would have worked reliably over time. but at least we do have a 3.5mm stereo out and microphone input connector, just like we don't find on a Raspberry Pi 5. Turning to the main short edge, in addition to the two headers I've already noted under the board, things are also an improvement on a Pi, as we have 3 Type A USB 3.2 Gen 2 ports, or in other words, the 10 gigabits per second version of USB 3, along with 1 Type A USB 2 port, and the Ethernet port here is 2.5 gigabit, which I know will make some of you very happy indeed. Finally, on the second long edge, we find a power over Ethernet header and a 40-pin GPIO connector, which is connected to an RP2040 microcontroller down here. And this also has its own boot select button. And so there we are, the Radxa X4, a very nicely specified Pi form factor single board computer, which in my view is only let down by the use of these pesky micro HDMI ports. Now, before we can get this board up and running, in addition to refitting the wireless antenna and the real-time clock battery, we need to do 2 things. Firstly, as there's no eMMC on this board, we need to fit an SSD, which is going to be this 256GB integral PCIe 3.0 model that cost me £35.95, which is about $47. And I should note that this drive is rated with a 3000 megabytes per second read speed, but only 1800 megabytes per second write. And so we need to remember this when conducting our performance tests. So let's fit the drive. There we go. And the second thing we need to do is to think about cooling. So let's open up the official heatsink case. What do we have in here? Get this out. There we are. Down on the floor over there. And how's it coming out? There we are. And oh look, this is the official case. That looks like a thermal pad. That looks like another thermal pad. Those are, I think those are sticky feet, because this is a case thing that I think it ends up like that with the board upside down, and this obviously fits so that this is in contact with the computer itself, with its N100, and it keeps it cool with a little fan on the top, although this fan I've noticed is only a 2-wire fan, so it's clearly going to be either on or off. There's no speed control going on here. And I have seen some reports that the actual distance between the metal here and the top of the N100 is rather large, even for using a heatsink pad. So let's just have a quick trial to see exactly how well this fits together. And here we are. I've bolted the board to the main heatsink section. The piece like this just comes off. We can put that back on when we need it. And as you can probably see, there is quite a sizable gap between the metal and the dies of the N100. I would guess it's a good millimetre, which is only just about going to be filled by the provided thermal pad. So what I'm going to do is to use one of my own thicker thermal pads like this, which, as you can hopefully see here with the board mounted, has very much filled the gap. And if this doesn't deliver effective cooling, I will later on try using a copper shim. I've got some copper plate here, which I could use to fill the gap, and I could use with some thermal compound. But initially we'll experiment using the thermal pad, so I'll now put this piece back on the case, which means we're now ready to test this N100 SBC. Greetings! Here I am back again with the computer up and running. The fan is spinning, as you can see, and as you may be able to hear, it's also making quite a bit of noise. Although we'll come back to that and thermals a bit later in the video. Because for now we're going across to the desktop, where as you can see we're running Windows 11. This runs very nicely on this system. It's nice and responsive. We've even got, oh look, Copilots available if we really want to play with it. I don't think we will. And it is worth noting that whilst Windows 11 works very well on this system, setup took a little bit of time, because initially Windows couldn't find drivers for Ethernet or Wi-Fi. And so what I had to do was to plug in a USB to Ethernet adapter. That worked fine first time. And then I went to the web to a page I've got bookmarked over there, and this is a page from Radxa that provides all relevant drivers for the system. I installed these drivers and everything worked, no problems at all. So do be aware that whilst Windows 11 works very well on the Radxa X4, you might have to mess about a bit performing the setup. Whilst we're here in a browser, let's go to YouTube. I'm sure you want to see YouTube playback. It is of course fine on an N100 system, but let's just bring up my test clip. Make sure we're in 4K. We're definitely in 4K. Let's bring up stats for nerds. And well, we've got one drop frame as it settled down, but either if I move the mouse around and things, we've got no problems with 4K playback on this system. I wouldn't expect there to be. You get good video playback on an N100 computer. But it's good to see it, and it's also always good to see some ducks and some geese. And the final thing I want to do in this Windows part of a demonstration is to run up Crystal Disk Mark, which I've installed over there, so we can test the speed of the NVMe SSD. So let's run all the tests and then use the magic of filmmaking to speed on through. And there we are, it's finished, and the headline results of 3,135 megabytes a second read and 1837 write actually exceed the ratings for the SSD we fitted, which is no bad thing. And more generally, I continue to be very impressed with the Radxa X4. Now, just before we move on to Linux, thermals and power use, I thought you might like to see how similar the Radxa X4 in this heatsink casing is to this, which is a Raspberry Pi 5 in an Argon Neo 5 case. The only big difference is if we turn them over, you will see that underneath we have got, well, nothing on the Radxa X4, it's open, whereas it's closed on the Argon Neo 5 on the Pi 5. But both of these are very, very nice SBC systems. SBCs have come on so much, these are very viable mini PCs. Although in this video I'm not going to do lots of comparison tests between a Pi 5 and the Radxa X4. Why not? Because I made that video earlier in 2024. I did a video comparing a Pi 5 with another N100 system. The results won't be very different, and from that video we know that an N100 system outperforms a Pi 5 in a Sysbench test, in a GIMP filter test, and in a Kdenlive render test. Although we also know that the Pi 5 uses less power, and I can tell you here that it also is quieter this system than this one due to the noise of this fan. However, something that the Radxa X4 can do that this system can't is to run my favourite Linux distro. So let's move on and do that. Well now, here we are running Linux Mint. No, we're not. We're in the UEFI. We're in the BIOS. I just thought I'd show you we've got one of these available on this x86-based SBC. We don't have one ARM SBC, so it's always exciting when we've got one to look at. And there's lots of things we can configure here. If we look, for example, in power and performance under CPU power management control, we can control all the different power levels. We just have a look here what we can control. It is possible to set the different power states, which is always good to see. However, what we don't have here is anything to control the fan. At least I can't find it. Maybe it's hidden deep down, but as I say, I can't find it. And I guess this isn't really a surprise, given that we've got a simple 2-pin fan that's either on or off. I'm sure you're interested in power use, so let's bring up a power meter. And as you can see, we're using about 12.2 watts currently sitting here in the BIOS. So let's come out of it, discard changes and exit like that. And we will now boot into Linux Mint. All the power use has gone up, about 15.7.8 there, they've gone down a bit now. I'm going to commentate on a figure going up and down as we boot. Anyway, as we boot into Linux Mint, it'll come up in a second. Come on computer, you can do it. As we boot into Linux Mint, we saw 19.8 there on the power. As we boot in, I'll let you know that this installed no issues at all, and I need to log in like that. And Linux Mint works very well indeed. And as some of you will know, I use an N100 system for a lot of my computing. Everything other really than video editing and that type of thing is done on a desktop N100 system. And I use Linux Mint, so this is exactly what I run every day, and it works very well indeed. we've got down here the system monitor. You might want to see that. There it is. And I've also got a little thing here, P sensor, which will enable us to see temperatures. And right now we can see the processor's running along at about 40 degrees for the package temperature. These are the core temperatures, which are pretty close. And what I thought we'd do is to stress things out. So let's get rid of that a second. I'm sure you've had enough of that if you wanted to see it. And we will just bring up a terminal, and we will bring up this sysbench command to stress out the processor factoring prime numbers and take a look at what happens over here. We've got to 73 already, 77, 78, 80. In theory, this chip will go to 105 before it has major problems, so that worries the life out of me. 81, 80, where's it going to go? I know it's going to go because I've done this already, 82. Let's just keep watching because this is rather interesting. At least there we are, it's gone down now, 73, 66. I think this thing is throttled. The cooling on this system I think is not ideal, using a thermal pad to bridge a large gap between the heatsink and the CPU dies. And so what I'm going to do is to change things around, fit a copper shim to see if we can make things better. Right, here I am back again with much better temperatures, as you can see. We're now idling at something like about 25, 26, so pretty much 15 degrees lower than we were idling previously. And what I've done is to use some thermal compound to fix a piece of copper to the heatsink, and I've also put some thermal compound, quite a lot of it, onto the processor die so it'll fill any gaps that are remaining, and I put everything back together, and as we can see we've got the results. So let's bring up the terminal. I'm going to run the sysbench command again, and last time it took just under 30 seconds before we throttled. So what I'm going to do is to bring up a little watch like this. There we are, and I will start things off. There we go, and we'll see what happens. Obviously the temperatures are going to go up, and they are going up. And I think what we'll do, we'll go ahead a bit in time and see where we are. And we've now just passed 30 seconds, so we're now where we were last time when we throttled, if you see what I mean. And clearly we're nowhere near that. We're in the sort of the mid-30s-ish, which is very good. But we'll run a few more minutes and see where the temperature gets to, because clearly the heatsink is going to keep warming up. And here we are, having run for over 5 minutes. And things seem pretty stable. We've hit a 39 a couple of times, but things are clearly running very well. I'm very pleased with these results. I'm more pleased than a very, very happy person who's just received some particularly good news. However, as you can probably guess, what I now want to do, oh look, we've hit 40, what I now want to do is to see what happens when we remove the particularly noisy fan. So I'm going to do that. And here we are back again with the fan disconnected. As you can see, we've been running with no fan rotation for a little over 5 minutes. So let's go back to the desktop. Here we are. And as we can see, temperatures are lower than they were with the fan using the thermal pad. We are at about 35-ish idling along. It's been creeping up across the 5-minute period. You'd expect that, wouldn't you, with just the heatsink in play? But this is a good result. And the machine is beautifully quiet. But I guess we should try stressing it out, the poor little thing. Let's try a sysbench test again. And again, we'll bring in our little watch like that and start it off. There we go. And we'll see how rapidly things go up this time. Oh, they've been jumping quite rapidly, haven't they? Let's speed on through. And there we are. After 5 minutes this time, we've hit no more than 54 degrees. Massively better than we saw previously with the heat pad and the fan. As you can probably guess, I'm not going to be reconnecting the fan. And you probably want to know how hot this is, and it's perfectly touchable. The heatsink has certainly got warm, much warmer than it's got previously, but it's not an issue. Nice to warm your hands on in the winter. And so what I think I've definitely proven is if you get a Radxa X4 and the official heatsink, it is very wise to fill the gap between the processor and the heatsink using a copper shim and thermal compound. So, what more can I say? Well, not a lot really. The Radxa X4 is a fantastic single board computer, and in the next video I plan on using it to run a very interesting operating system. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.